Let us see about algebra of vectors. We shall see. What we shall see today? Algebra of vectors we shall see. Let me consider a vector A. Let me consider a vector A. Now you know already well about vector A. Let me consider one more vector of vector B. I'll consider. Now let me do one thing. Let me bring this vector to this position. Which position? To this position. Let me transfer it from this place to this place. Okay. Then vector B is coming here. Okay. Now it is two vectors are added now. Alright. That means one vector is followed by one more vector. Means we can add this. We call that as a what will be the resultant vector. Here vector A was here, A is here, B was here. We have replaced that place to this place. Now you can see this figure that vector A and vector B is like this. Okay. Now what is the resultant vector? Resultant vector will be like this. Resultant vector will be like this. It will be in the direction, okay, opposite to the direction of this. This type of the addition of the vector, we have got two types. In that, one type of the vector addition is called, what we call for this? Triangular law of vector addition. Triangular law of vector addition. This we call that as a triangular law of the vector addition. Is it clear about the screen to you guys? If two vectors represented by two sides of a triangle, what we say? Two sides of a triangle. Taken in a order, then resultant vector in reverse order we shall write. Resultant vector taken in reverse order. That means we shall consider ABC. Okay. We shall consider triangle ABC. In ABC, what I can write here is triangular law of addition. Here, in triangle, resultant will be taken in the reverse order we said. Okay. Now, we shall write like AB, or else we shall take AC, vector AC. We should consider actually vector AC is equal to AB plus BC. But we consider that AB as a vector A plus vector B is AC. See, this is the triangular law of vector addition. Now I will concentrate more on this point. Resultant vector taken in order. If we did not take in order, what happens? Let me show you. Okay. Is this clear to you this much? Vector law of addition here you write, because I need some space. Why it will not be equal? Now see here. Observe here in this part, guys. Same diagram I am going to draw. Now you consider A is like this. One more thing you understand. When can we find resultant vector, or else when can we add the vector? Keep in your mind. See, terminal point of one vector. See, terminal point of one vector must coincide with initial point of one more vector, then we can add these two vectors. Is this clear to you? Initial terminal point of one vector, terminal point of vector A is coinciding with initial point of vector B, then we can get resultant vector as vector A plus vector B, we can get it. I think this one is clear to you. Now let me show you why it is in this direction. See here now, this is one more direction. Actually he says that it should be taken. See here, it is going in this direction. Understand here, it is going in this direction, but resultant we are taking in this direction, correct? So direction is opposite. The arrow mark is here, further arrow mark is here. Actually it should come like this, but resultant will go in opposite direction. Why it is like that? The reason is, now mathematically let me show you. If this is ABC, okay, if this is ABC, we shall write like AB, AC, vector AC is equal to AB plus BC. Is this visible to you guys? To add vector, resultant, no need to add vector, okay. Initial point of, what is that? Initial point of one vector, initial point of one vector must coincide with terminal point of one more vector, or else second vector we can call one more vector we can. Is this clear to you? One more vector. Next, if you completed this, let me go for triangular law of vector subtraction. I'll go. It's again simple, guys. Once if you learn this now remaining things will come. Subtraction, Vishal. Very simple. If you know addition, knowing subtraction is very simple. Okay, let us go ahead. Now, this is for example, okay, let it be like this only. Now actually this is A, this is B, this is B. Now, let me consider this one in, this is B, I'll consider, this is A, this is B. Now, let me consider this B in negative direction. See, already you know that B is in one direction. It was in which direction? See here, this is very important writing like this. Now, B's direction has changed. Already you know that. If direction has changed, we write that as minus B. So, resultant vector will be formed here, my dear students. Here there will be a formation of resultant vector. Even resultant vector actually A plus minus B. Again addition itself. But the value of this becomes angle A, sorry, vector A minus vector B. See, this is called triangular law of, otherwise vector subtraction. If it is in negative direction, we write that as A minus B. I think this is clear to you. That means if I want to write that in a statement properly, ABC. See, this is actually ABC, right? This is ABC. This also C dash, let me consider, whatever. Now, we know that AC is equal to, vector AC is equal to AB plus vector AB plus vector BC I can call. This I can call as a AB plus BC I can call. But in this figure, this is in negative direction, will you agree? We are considering, this is about which triangle? But here we know that BC is in negative direction. So let me consider AC is equal to AB minus BC. Otherwise you can write plus only, BC is in negative direction, you can write. So but we know the value of the BC, that is AB. AB value already AB. If you want to write, otherwise let us write here only minus BC. Here only we shall write minus BC. plus BC has become minus BC. How you will understand? Like that you write. Minus BC means minus BC. AB minus BC I can write. It is long method, but to make you to understand better, this is the right method. Therefore, AC will be, okay, AC will be this one vector A minus vector B. See, this is the vector law of subtraction. Is this clear to you? Vector law of subtraction will be done like this. Does anybody having doubt here? Here also we applied triangular law. Don't be confused. Here also we applied triangular law of addition only. But the negative direction there is a vector. Therefore we have written like. I hope this is clear to you, right? We shall consider one figure, that is, this is vector A, this is vector B. This is vector A and one more is vector B. Now we shall consider vector A and B are the vector A and vector B are the sides of a parallelogram. Okay, let we shall write like that. Let vector A and vector B are the sides of parallelogram. Are the sides of parallelogram. Are the sides of parallelogram we shall consider. Now, in the previous concept, you came to know that if I draw two sides of a triangle, then you came to know that resultant will be formed in third side of a triangle. Now I am giving one more case where the sides given in a sides are the sides of the parallelogram. Vectors what I have considered are the sides of the parallelogram. Then where the resultant will be the question. See, if I make this still more a big figure, because it is not so much visible, I believe it is A. If I consider this is B, so already you know that in parallelogram opposite sides are equal. In parallelogram opposite sides are equal. If this is A, this also will be A. If this is B, this also will be. This is, see, this law is called by, see now, if we consider two vectors as a sides of a parallelogram, then resultant will be formed on diagonal. Understand this? Resultant will be formed on the diagonal. This law is called parallelogram law of. First is we learned parallel, this one triangular. This is parallelogram law of addition. We call this as parallelogram law of addition. I think this is clear to you. Parallelogram law of addition we call. Is it clear now? How can we write? See, actually both also same. Now you forget this top figure. Now this is triangle. This is side. If I want, I'll make it ABCD. Let me call as a parallelogram. Look at here. This is AB, side of a triangle. Even this also. This is BC, side of a triangle. Then this is a triangle. This is also side of a triangle. So though we have written parallelogram, it is half triangle. Therefore, triangular law and parallelogram law, there is no much difference in this. Both also almost same. For that, I'll give statement at last. Now let us write what is parallelogram law of. What is that? Addition. If we have considered already, then if let we shall consider if A and B are the sides of the parallelogram, then resultant will be formed on a diagonal. Then resultant formed on formed is a diagonal of a parallelogram diagonal of a parallelogram is called parallelogram law of vector addition. Here no much difference. AC is equal to AB plus BC. So AC value means AC is diagonal. So AC will be equal to angle A plus angle. I'll erase this. Now let me go for vector subtraction. We shall go. In triangle also we learned vector addition. Here we shall learn vector subtraction. Okay. But observe here, small changes I will do. This is in this direction, correct? The direction is very important in vectors. Look at here. This will be in this direction, I'll consider. That means B will be minus B. Now, according to that only we shall write nothing new. AC is equal to AB plus BC. Because here the BC is in negative direction. Therefore, A plus, but BC value is minus B. So angle vector A minus vector B. See, this is what this one parallelogram law of subtraction. One note you take along with this triangular law. That's what I said now. Triangular and parallelogram law of vector addition are equal. One note you take. Nothing difference, but if I consider parallelogram, it forms diagonal. If I consider triangle, it forms third side. That's all.